So we are going to write sums, and we are going to use the summation notation. So there is this symbol that we use for summation notation. It's also called the sigma notation symbol. This is a capital sigma in Greek, so they call it sigma notation. This tells us that we're going to add up all the terms in a sequence. When we add up all the terms in the sequence, we call it a series. So this word right here, series, that means add up all the terms in the sequence. And that's basically the majority of our chapter is sequences and series. So the terms in a pattern and adding up the terms in a pattern. There's a teeny bit more that has to do with sequences and series, but for the most part, that's all we're talking about in this chapter 9. So what happens when you have this sigma notation is at the bottom, you will have a variable. Particular example says I equals 1, but it does not have to be I and it does not have to be 1. Another number. Okay? And right next to it, you will have a formula. You will have like 2n minus 3. You will have a formula right next to it. You'll have an expression. And what this notation tells us to do is plug in this bottom number, which we call the lower limit of summation. That's the bottom number. It's going to be the lower limit. The top number is called the upper limit of summation. And the I itself is the index of summation. That's it's just a variable. So we're going to plug in, for this particular example, I'm going to plug in 1 first into the formula, and I'm going to find that first term. Then I'm going to plug in 2, and I'm going to find that term. And I'm going to plug in 3, and I'm going to find that term. I'm going to plug in, I'm going to find that term. And I'm going to keep doing it until I plug in the top number, which in this case is n, but it would actually be a number. And then we add up all those terms, and that's the answer. So here it says find the sum. Upper limit of summation tells us to plug in what number first? 1. So we're going to do 3 times 1 minus 1. That's going to be our a sub 1. So 2. Yeah. Next one is plug in 2. So 5. 3 times 3 minus 1. 3 times 4 minus 1. I should have written smaller. 8. 11. And then 3 times 5 minus 1. 14. That's where I stop. Why? Why did I stop? Because that is our upper limit of summation that says plug in all the terms in 1, 2, and 7. How many different numbers did I get? 5. If I subtract 5 minus 1, do I get 5? So you cannot here and say that's how many terms there are. You cannot subtract them and say that's how many terms there are. That's going to be important later. Okay? I just want you to notice that when I have a 5, there's not 4. A lot of people like to subtract them and say, oh, 5 take away 1, there must be 4. There's 5 terms here. Now we're just going to add these up. So I'm going to do 2 plus 5 plus 8 plus 11 plus 14. What'd you get? 40. Yeah, 40. Okay. So the answer to this is 40. All right, the next one. We're going to start with plugging in 1. Where do I plug in 1? Into the K, right? There's not a K. Well, so what is the value of the first term? What is the value of the second term? What's the value of the third term? How many terms am I going to do? So what's the sum? 18. I don't think we have like any of those, but just to show it to you. Okay. So what am I going to plug in first for this one? I am going to plug in 0. So we'll do negative 0 squared, which is 0. Then I will plug in. Now when you square and you have a negative, you have to look at order of operations. You're going to square the 1 first, then make it negative 1. So how many terms are there? See how you want to say 4. You do, don't you? It's 5 terms because it goes from 0 through 4, including the 0, including the 4. Now we're going to add those up. What is it? 30. So that is. There are some of these that we either can't or don't want to do by hand for us. Now, I need to help you guys perhaps individually. I'm going to do, if you have the older calculators first, who's got, I mean, no, not the older ones, the newer ones first. Who's got the older one now? Who's got? You can check if you use second math. No, you just go to math. I'll show you what you need to have.
Math 0.
Yeah. If you have math 0, here, I'll put mine under there so you can see it. Because some of you have older calculators, but not the super old, or have the super old ones. Math, and then you go to 0. If you have this symbol, oh, it's very easy to type it. It's the people that don't have that capability. You are one of them. If you have this calculator, I know yours won't do it. So you get to learn a different way of doing it, which is in our notes. I'll show you how to do it. Who else? So I know who I'm helping you. There's Dylan. Who else? Does yours have the summation thing? If yours has the summation thing, look in your notes and see what to plug in. Does yours have the summation thing? Yours has the summation thing in it. Look at your notes, see what to plug in. I'll do mine. I'm going to help Dylan and Neem real fast. Dylan, come over here. We're going to type in this. You got it, or are you just figuring it out yourself? It's not. It's not on your calculator. It's on yours. Is there anybody else who didn't have it on their calculator needs to? Yes, that's your calculator. Did you figure it out? factorial? Yeah. Math probability. So you're going to type in x, and then go to math, go to probability, and then there's factorial. Okay. And then we're going to divide by 2. You do not have to do that. Wait, what are you doing after? And then you have to use comma. And then x, comma 1, comma 5. So what you're telling it is you're telling it the Okay, did you get the answer? Yeah. Okay. So then you just have to memorize how to do that, and after times, hopefully remember it. I'm going to do it on my calculator. So again, I got here by just doing math. Oops. Delete. I did math, and I went up to 0. Help the people that do not have this on their calculator. So we need to tell the calculator which variable we're using, and you can use any letter that you want. So you don't have to use an X. And then we have to tell it the lower summation is going to be 1. We're going to tell it the upper summation is 5. And then we have to put in the equation, which if you have forgotten, if you have the super newer calculators, alpha, y equals enter will make it a fraction for you. Again, that was alpha, y equals enter. We'll make it a fraction. Less parentheses to deal with. So then I do x and then math over to probability, and then number 4 is factorial. Bottom 2. And then 153 over 2. If yours told you like 76.5 or something like that, you just hit math, enter, enter. I'm going to hit it, but mine's already a fraction, and it changes it into a fraction. So this is how we can use our calculator. There will be some that you do on calculator, there'll be some that you don't. Okay, on this one right here it says use sigma notation to write the sum. So what this is asking you to do is not actually find the sum. It's saying find the sum. It's saying use sigma notation, as in just write this as sigma, and we have a number on the bottom, and we have a number on top, and we're going to have a formula here. Okay, so this is what we were doing the past 2 days, where we're trying to find the a sub n. We're putting it into the sigma that represents add them up afterwards. Okay? I'm not asking you to find an answer. I'm just asking you to write this thing. So what's something that we definitely know about this formula? We definitely know n equals 1? Okay. Top is 15, the upper summation. I couldn't remember the word. What else do we know about the formula? 5 on top over 1 plus n. That's all I have to do for that question. I'm not actually finding the answer. You do not have to find the answer. Okay. Next one. Same thing. You can use whatever letter you want. I like using n's, but you know, you can use whatever letter you want. Is there anything you know right now? It is alternating plus minus. So that's going to tell me what about my formula? Okay, so that was a little hard for me to hear. I don't know who's talking. Was that Neil?
Yeah, something to the end. It's going to be like a number to the power of 1.
Right, but that something is -1.
Yeah.
Yes. So it's going to be -1 to the power of, is it going to be the power of n, or is it going to be the power of n minus 1? Oh, no. So if I plug in 1, will I get out a positive? If I plug in 1 right here, will it be a positive number? Will not. So then I do need it to be n minus 1 to change the alternating negative. So we're going to have -1 to the n minus 1, and we're going to multiply that by the rest of the formula. So what else? What else do you know about this? It's a what? My ear's messing. I can't help that my left ear faces you guys. What? It's a fraction. Yes, it's a fraction. Okay. That's it? 1 over. What are 2, 4, 8, and 128? This is 2 to the first. This is 2 to the second. 2 to the third. 2 to the... It's not nth. Oh, I mean, what gives you 128? 2 to the what gives you 128? Is it 1, 2? Is it there? What you guys are doing to me? 7. It's 2 to the 7th. All right, but what's the first one that I didn't really have written over here? What's the first one? 2 to the 0. So there's actually a couple different ways you could write this. I hear 2 to the n minus, but that would be if my first n was what? And I put it into 1 minus 1, then I would get 2 to the 0 here, right? If I make this 2 to the n minus 1, what do I have to plug in to get 7 here? 8. This is one possible answer. Actually, I'd probably simplify this. I'm going to rewrite it a different way. I'd probably simplify this to go n equals 1 to 8, and then I'd probably go -1 to the n minus 1 over 2 to the n minus 1. Ooh, maybe I'd simplify it further. Maybe I'd go n equals 1 to 8, and I'd do -1/2 to the n. I have a few different ways. These are all equivalent using exponent rules that I'm sure you guys rocked last year. Okay. There's another way I could have written it. Instead of writing n equals 1 at the bottom, you would go from 0 to 7. -1 part would just be to n. Because if you plug in 0 as your first number, that would become +1. And then the bottom would be 2 to the nth. And if I write it that way, I could also write n equals 0 to 7. We could have -1/2 to the nth power. Okay, so I just wrote it like 5 different possibilities. There's you know, we might have where you write it one way and I write it one way, and they are exactly the same, but they don't look the same. So it may take us a little bit longer when we grade things for this section. Okay? Can't hear you. Or you're not talking to me? Okay. Okay. All right, the last is finding partial sums and finding infinite series. So if it says find the fifth partial sum and they give you something like this and it says find the fifth partial sum, it only means do this. That's what finding the fifth partial means. Find the first 5 terms of the infinite series. You see how they're not asking you for the full thing. They're asking you for part of the sum. They're just asking you for the first 5 terms. So it just needs to do this. See that that wordage means to do this. Okay, I'm not going to do this one because I already showed you how to do this stuff on your calculator and without your calculator. I want to go over the last one. Okay, I can show you this with or without calculator. This says find the sum of the infinite series. That means that I'm adding things up forever and ever and ever and ever, but there is an answer. I know, it's crazy. So what would be our first term? If I plug in 1, what would we get? If I plug in 2, I would get 1/100th. If I plug in 3, I would get 1,000th. And actually, these aren't commas. We're adding them, right? If I plug in 4, I'm going to get 10,000. And so on, right? Forever. I'm going to change those into decimals. So 1/10 is 0.1 plus 0.001 plus 0.0001 plus can we add these up? It's going to be 0.11111 or 0.1 repeating. Any fraction, not fraction, any decimal that ends or repeats can be written as a fraction. It's called a rational number. Any decimal that ends or repeats can be written as a fraction. Does anybody know this fraction? It's 1/9. It's 1/9. Yeah, if you, real fast here. 1 divided by 9 is 1/9. 1/9 is 0.1 repeating. 2 divided by 9. 3 divided by 9. You see how those are all decimals? What's 0.7 repeating? This is off on a tangent for a second. 0.7 repeating equals what? 7/9. What's 0.6 repeating equal? It equals 2/3. It's 6/9, but it's 2/3, right?
What about 0.9 repeating?
0.9 repeating. I can show you proof if you really want. Do you guys know that? I have a proof for it. Kate's going to miss it, but everybody else is going to hear it. Oh, wait, nope. Matthew's going to miss it. Huh? Okay. So what is our answer for this? If we add all these terms up, we get 1/9. If I'm going to ask you to do something like this without a calculator, there's got to be a pattern. Otherwise, you won't be able to do it out a calculator. To do it with a calculator, you just type it in. I don't want to do that real fast, but I do want to do one without a calculator. With a calculator. I want you to do, let's do equals 1 to infinity. And we'll do 4x as our formula. Your calculator, you cannot type in infinity. So you have to get your summation symbol. You're going to have to tell it that we're doing x, and we're starting at 1. You're going to have to tell it 4x is the formula. But what you can't tell it is infinity. So what we have to do is we have to start with a number, and then put in a higher number, and then put in a higher number to see where the numbers are heading. So when it's infinity, we're just going to pick a number to plug in. Somebody yell out a number we could plug in.
9 billion.
No idea what we all said. Somebody? 3?
9 billion.
We're going to infinity. 9 billion won't work. The calculator will be like, it's too big. Forget that. Do it yourself. How about
21.
25? I don't know. 25 is 1,300. Now, to get that again, I don't want to retype all that in. To get that again, you can do second enter, and it pops the exact same thing up again, but now I'm going to go change the top number to, how about 50? And now it's 5,100. Okay. So I'm going to go change it again. Second enter gets the same question. How about 100? It doesn't look like it's getting very big, so. 20,200. All right. How about, what should we try after 100? Ooh, I wonder if 1,000 will work. Nah, I think it's quitting. Oh, it didn't quit. Do you guys know what we're trying to do by plugging these numbers in here? What's this symbol mean? Okay, I didn't find all the terms. But if my 4x, every single time I plug in a number here, what's happening? It's getting bigger. And if I add on a bigger number, it's going to get bigger. And if I add on a bigger number, it's going to get bigger. If I keep adding these up, what number am I going to have? What is this getting closer to? Oh, yeah, I couldn't hear what you were saying. Infinity, right? The only way you can actually get a sum other than infinity is if the number's getting smaller.
So it has to be a fraction in the rate.
To actually get the sum, because these are just going to get bigger and bigger and bigger and bigger. There is an answer. It's infinity. But your calculator won't tell you. Your calculator will tell you if it's approaching an actual sum. If it's getting smaller in your smaller amounts, then we can get it to an actual just number. But because this one's getting bigger, it goes on forever. The assignment is written in Canvas on today, and it is in the book. It's 9.1, so you already downloaded it. But it'll be involving the summation symbol this time. A lot of it's the same stuff we've already done, just writing the summation symbol or adding up the terms.